Now we're going to look at how to convert from Cartesian coordinates to polar. So if we have a Cartesian coordinate, we have our x location and our y location, and we have that point that exists. But instead of having an x and a y, we want to convert that to a theta and an r. And so what you might see is it's just kind of the reverse of what we just did. So here, our r is, of course, going to be the hypotenuse of that side, and our theta, so our r is going to be, r squared equals x squared plus y squared, a little Pythagorean theorem, and their distance formula. And then theta, of course, is just going to be the inverse tangent of y over x. And so when we're solving vectors, it's just that same sort of thing. And so these two formulas are used all over the place. R squared equals x squared plus y squared, and tangent of theta equals y over x. And so if we have an xy coordinate, we should be able to translate that into polar coordinates. And so I would like you to find two sets of polar coordinates. I want you to go ahead and pause the video, and even if you just do one set, or if you do half of these and find two sets, that's a good thing, but find at least two sets of polar coordinates for most of the points below. Go ahead and pause the video now, do that, and then you're going to notice that your answers might vary because of the fact that polar coordinates are not unique. Okay, you've unpaused the video and hopefully you had some answers. Here are some potential answers. One thing I want you to notice is the radius of all of these on my list here is always the same unless the radius is opposite. Okay, and when the radius is opposite, usually that's going to imply that the angle is maybe pi units away because it's a reference angle. All right, in a different quadrant. And so which of the following here, it asks, which of the following is not a correct coordination of 2, 3? What's interesting is instead of doing all the, quote, math for it, maybe what you could do is just ask yourself, what quadrant are all these in? So 2, 3, of course, is in the first quadrant. And so if you have a positive angle that's less than pi over 2, right? Pi over 2 is approximately 1.57. I hope that's right. And so that's approximately what pi over 2 is. And so this is less than pi over 2. This is positive. So obviously it's in the first quadrant. Here, this is bigger than 2 pi, but less than 2 pi plus pi over 2. So this is just actually this plus 2 pi. So this is also in the first quadrant. This has a negative angle that's less than pi, but greater than pi over 2. So it is over here somewhere, looking this way, but it's a negative radius. So this is in the first quadrant. And then this one is negative angle, but less than pi over 2. So it's looking here, but it's a negative radius. So this is in the second quadrant. So the only possible solution, incorrect one, is this. And of course, you could check your x equals r cosine theta and r sine theta if you wanted as well. Now we're going to look at graphing. And, if we had more time, we'd really get into the graphing of these things. We'd look at more of what these graphs can look like. And your book goes into some detail on that too. And if you want to look up other videos, you're welcome to. But I think the most obvious graph is going to be, r equals 2. Well, think about that. That's just the radius equals 2. And so what's that going to be? Well, of course, it's just going to be a circle that has a radius of 2. And shame on me for trying to draw a good circle, but I think, yes, good old Notability will do it for you. Okay, and the next one, where r equals theta. Think about that. So what does that mean, r equals theta, and go from theta equals 0 to pi over 2, or 2 pi? So when r is, think about the implications here. When r is 0, right, that means that theta was 0. So at 0 degrees, you're at 0, so that's at the origin. And then at pi over 2, right, when theta equals pi over 2, that implies that r equals that 1.57. And man, I really hope I'm doing this on my calculator real quick. I really hope that pi over 2 is 1.57. I'm not totally messing this up. Okay, it is. For some reason, I felt like it was wrong. And so at pi over 2, it's 1.57, so your angle's here. But what did it do in between those 2 points? Well, I mean, at any point in here, it kept getting further and further away from the origin, right? And then at theta equals pi, your r is 3.14. So you're 1, 2, 3.14 away. And so it keeps getting further away from the origin. And at 3 pi over 2, well, here, how about at just 2 pi? It's going to be 6.28. 1, 2, 3, 4, 5, 6.28. And so you just keep getting further away. And I know that I'm not getting the intersection down here correct, but you can kind of see what the flow of this line or this curve is. And then for the last one, we have theta equals pi over 4. Now this is interesting because we want our polar functions to be r of theta. So it's r as a function of theta, just like usually in Cartesian coordinates, we do f as a function of x. But notice here we just have theta equals pi over 4. So what is that similar to in function notation in rectangular form? That's like when we have x equals 5, which of course is like a vertical line. And so when r equals theta, if you think about it, that means the radius is always at the angle of pi over 4. And so if the radius is always at the angle of pi over 4, think about what kind of an angle we're looking at. We're looking at an angle that's always pi over 4, and the radius is going to be whatever fits that. And so it's going to be a line, interestingly enough. So that's interesting. And then the answers are here in your packet for you. Now, for these, we're getting a little more difficult, and we're going to make a third video for this.